And hello everybody, this is the re-recording of week 2. The first attempt didn't seem to work for some reason when I uploaded it into Echo 360, so when I tried to put a link in it didn't work. So here we go again. And what I have to say first of all is you must watch the old lectures before these new top-up lectures, because I don't generally repeat exactly what the previous lecture said, although those old lectures have got a lot of information in that is very helpful to you in addition to the study guide, but I'm just topping up a few bits and pieces here that I think have either been overlooked or need to be amplified somewhat. So let's just have a flick through. It won't take very long to do this on top of the old lecture, which I hope you've all watched as well. So maintenance costs. You know, we need to get it really clear in our minds exactly what maintenance costs are. There's two definitions here for what a maintenance cost actually is. It can either be an activity that is needed or that you actually go and do it to try and keep something as close as possible to its original condition. So that's an asset, a building, a piece of equipment, whatever. I mean, it could be a sports ground. But you're allowing for normal wear and tear. So you're not really repairing normal wear and tear that's expected, but you're doing other things to keep the asset, the building, close to its original condition. Now, bearing in mind, the original condition can change throughout the life of a building. As I've said previously, what is an individual person's office could become a storeroom, or could become a photocopier room, or whatever. And therefore, the condition and functionality of that area can change, and that must be borne in mind. The second definition is really a different way of saying the same thing. It's the actions that are needed to retain a piece of equipment or restore it back to its specified required condition, which may not be as brand new, but as long as it's achieving its desired performance and outcome. And it also makes sure that you get the maximum life out of it. So by applying maintenance to, say, a pump, you can extend its useful life probably by 50 to 80% over if you just turned it on from new and left it, and it would fail without any maintenance. So by adding maintenance into it, you can actually extend its life. Life cycle costs themselves, just to break this down several times, this is hammered in the old and this new lecture as well. This is a healthcare facility, say a hospital or a clinic. The operation cost of it is 45%. So that's actually to operate it, the costs of operating it. 42% of the costs are the utilities that you use, your power, your electricity, etc. Operations can include staff wages and things as well. But only 13%, notice, only 13% is connected with the actual construction, from the design, construction, planning, transition to handover. So 13% of the cost of the building, and remember, we tender for buildings, and it's always selected on the basis of the lowest tenderer, well, normally the lowest tenderer, for the construction, from design to handover. No one seems to really consider the other amounts that we've got up here, sort of thing. So you've got to bear in mind that the running costs of the building far exceed the construction costs. What's the operational cost? Well, they've disappeared, haven't they? I haven't put them in. What's stupid me? Operational costs are insurances, cleaning, staff wages. It can be all the utilities, as we saw. What else is operational? Staff salaries, transportation, postage, catering, cleaning. It goes on. It goes on and on and on. I'll let you find out some of those yourself, but they do get mentioned in the old lecture. The life cycle costs here, the things I want to go. If you have a look at the top one up here, then that's the general life cycle of something. So we call it, this one's taken from a information technology basis, but is the same for buildings more or less. The acquisition part of it is the design, planning, feasibility, tendering, construction and handover. And then a little bit of maintenance going on. 20 to 40% absolute maximum. That's a bit high for a building. Buildings will be more around about your 20% maximum. And then to operate the building, which will be your regular maintenance, your breakdown maintenance, planned, reactive, utilities, minor repairs, upgrading where legislation requires it. That'll easily get you up to the 80% of the whole life cost over 30 years there. The total cost of ownership in the middle there is the capital expenditure for building and designing and constructing of a building. But it's a tiny, it says it's a fraction of the whole life cost. So, you know, you've got 1 to 1, 5's the actual construction and maintenance. Sorry, 1's the designing and the construction cost. Number 5 is the maintenance and operating costs, as it says, where's my mouse gone? Here. And then based on 200 people in an office, so it includes salaries as well as all the operating costs, is all of that. So the actual construction part is minimal over the life of a building, but often overlooked. Bring it down here, so design construction costs can be up to 20%, operating can be around 65-ish, maybe a bit higher than that actually, if you're in say hospitals or something with a lot of specialist operations and things going on there, no pun intended, could be up to 80 here, and then end of life costs, which could be selling it or demolishing it, can be up to 15%, especially if you've got an old building which has got things like asbestos or contaminated soil, or you're in a really inner city confined site, then your costs of end of life, if you're demolishing it, could be that high. This comes in, this is me updating a little bit on previously. So as we know, this goes through the materials side of it. So think of the materials in the construction. This is a building life cycle. So you've got recycling or demolition of old parts. That's the end here. But to start building, you've got to dig it out of the ground and make it, your steel, your concrete. Then you make your bits and pieces that you're going to build it with. Then you've got to transport it to site. Then you've got to build it into the building. Then you've got to operate the building for its life. Then halfway through its life or so, you might refurbish it two or three times to keep up with modern technology and legislation changes. And then you might demolish it at the end of life and recycle the materials and bring them back round in a circle. That's the green sustainable approach, which is more common nowadays to be sustainable in this manner. This sustainability, the sort of impacts that you can have on the building can have, is we start looking at, so birth, we build it, so you dig the materials out, so you've got environmental impact, you've got an energy and a cost. By using recycled materials, these are greatly reduced. Remember, the sustainability is one of the core key performance indicators on a project nowadays. Never used to be, but it is now. Clients want a low carbon footprint, a low sustainable impact development. You get up here, you're moving those materials to the site for manufacture. Again, there's more energy in moving them, and there's the environmental impact. Then you start building the building. Well, there's obviously an environmental impact, and there is energy costs again. So we're using energy all the time. If you think of energy, it's either petrol, electricity, whatever. Electricity is coming probably from a fossil-fired source. So it's all carbon dioxide going out into the atmosphere, more global warming going on. We need to minimise these as much as we can. And asset management has now taken this on board. When you're operating and maintaining the building, you've got energy costs and environmental impact. This is why we're looking for energy efficient fixtures, fittings and occupation patterns, minimal water use, try to come up with carbon neutral buildings that don't need too much heating, do not need too much cooling, they can do it naturally. And then when you knock the whole thing down or you renovate it, there's an impact, there's an energy cost. You really want to try and recycle as many of those materials as you possibly can. Doesn't mean you have to use them into your building. You can sell them for use in another building. And eventually you're going to demolish it, and you've got a lot of materials that, what do you do with it all? Do you just dump it in a hole in the ground, or do you try to reuse it? All things that need to be considered, especially actually at the feasibility stage. If you're looking at the building envelope, if you're having a look at an envelope to see what happens with it, you've got to inspect it. We're assuming this already exists before you go and do a refurbishment maybe. So you've got to inspect it. You have to have a condition report to tell you what, that will tell you what needs to be done. Then the consultants and that will come up with a design solution. Your architects and that will say, oh, we'll overclad something or whatever. Then someone's going to manage the project. So that whatever they come up with, they're going to manage it to completion. Then you've got to preserve the asset during occupation. And then you come round in another 10, 15, 20 years, you'd be back here maybe doing some more of this again. This would apply internally for services, for structure, for roofs, for cladding, whatever. It's a never-ending circle, basically. Now, one of the things that wasn't touched on previously is we now use a system called Building Information Management. And this tries to bring everything together into one model that everyone has access to. Now, Building Information Management is a separate issue all on its own. But it's a digital, the best way to describe it is a digital model of the project. So you've got a 3D, if you've seen 3D CAD models or stick models, you can see them online if you sort them out. That's just a picture, but a BIM is that plus interactive live-time information. So you can, if you see a water meter on the drawing, you can click the water meter, it'll tell you what the reading is. It'll tell you how much energy is being used if you click a room. I mean, I'm using very simple examples here. And it's often used, it's used for the construction management. You can clarify it for your specifications. They can be built up and designed in the system because this is running before construction starts. The facilities management, which would do the maintenance and etc., they will have a connection into the BIM themselves, and they may have feedback into the specifications to make sure that it's specified and finished to suit what the market wants. Procurement, obviously without saying. BIM is brilliant on your document management because everybody who's got access can get to their documents. They're all in one place. Traditionally, if I were to go and do an inspection condition audit or something of an existing building, I want to see all the documentation, and if I'm lucky, they'll put me in a room in the basement with a table and loads of filing cabinets, and that's it. I have to try and find things manually. With BIM, it should be able to be brought up on a computer using search words, etc. You can simulate things, so you can run how long will say how long will this type of carpet last in a corridor? It's X amount over the course of 30 years. How many times is that going to be replaced? What if I put a more expensive carpet in for the 30 years and it might be replaced one time less? Is that actually cheaper in the long run? You can simulate everything like that. The design of it, all the architects, the engineers, calculations, everything are all included in the system for you to look at and update as changes are made. Laws and regulations are kept in there and updated as necessary. Then there's the logistics of the thing, the servicing of it. And all that goes into one main database, which everybody can interrogate, and it's meant to be updated as things change. As you replace something, you update it. As you do a maintenance operation on it, the facilities management people will update the maintenance record in it so we know when it was last done. This is the way it's going. Building information management. When we go and do an assessment on a project or an existing building at a feasibility stage, we do something called a triple bottom line. So we now thought, it's all after sustainability again, and triple bottom line is mentioned in the old lecture as well. We consider the environmental impact of not only building it, etc., but also how can we minimise its impact whilst it's being used, so reduced energy consumption, etc. up there. A lot of that in a building will now have automatic data logging, so it's communicating all the time. as to what's going on in different areas of the building. Rather like security will tell them who swiped into which door at what time. There's the social impact of this building. What effect will it have on the health of the occupants? Is it safe? It's talking there about proper personal protective equipment, so that's aiming at the construction area and the maintenance side of it all. But you can also put that social towards the society outside the building. I mean, you're going to create more traffic problems. Some tall buildings can change the wind environment in cities and create vortexes and high winds. I mean, they should all be considered for that. There's the economic, obviously. Try to keep your running costs to a minimum. Increase the productivity of whatever's going on inside the building, which means if it's an office, you're keeping people happy and healthy. And where they all meet that's basically a sustainable building. The environmental part will give you a neighbours rating or a Green Star rating possibly. So that's called a triple bottom line: environment, economy, social. I threw this in just out of interest because people always ask this question of me. How long do things last then? If this asset management is going, how many times have we replaced the carpet I keep coming back to? How many times have we replaced that in a 30-year period or a 50-year period? This gives you an idea of what we expect an element to last. Foundations. Well, I know I come from England and we got buildings with foundations that are still working 1,000 years later. Might have been a bit of movement, but they're there. But modern foundations, we generally say about 110 years. Steel frame, concrete frame, they're in the low 80 years. And of course they are going to be refurbished and repaired, so you'll extend that if you're careful. Timber frames a little less, although this isn't really life expectancy for the new glue lam and cross-laminated construction methods that are being used for the high-rise timber-framed office buildings nowadays. You've got the laminated frames. Upper floors, you've got all the rainwater goods and different types of roofs, stairs, different types of stairs, plastic stair nosings, 15 years, a little bit on the very edge of the step. Well, from experience, I've never come across any that lasted that long. Aluminium stair nosings, yeah, maybe 15 years for those, but these, I wouldn't give them more than 10. But it changes depending on what the building is used for. So what might last 15 years in one building may last 5 years in another, or 20 years in another. It depends exactly what sort of use is going on. And sometimes you have to monitor the use. I mean, I've put CCTV cameras into areas just to monitor what's happening, so I can work out why is that wall falling apart, that door coming off the hinges, whatever. And you find out maybe it's the postal trolley goes crashing through it twice a day. Well, we've changed the type of door so it doesn't crash into it. It's an automatic door. That might help. Same thing, we've got external walls, windows, UPVC windows, we think 37 years. Yeah, maybe. Depends. We're in a very high ultraviolet radiation zone here, so there might be a bit less than that. Mind you, in Germany, they seem to think they're going to last about 50 years, but they don't get a lot of sun. Demountable petitions. I mean, it's all in here if you want to have a look at it. You can Google some of this up. But it shows you, these are just average to use. And they're very useful when you're doing condition assessment and you have to give an estimate how long something's lasted. So if you know roughly when it was put in, this might give you a guideline. But of course, remember, how it's used, who uses it, what it's used for will impact these figures. You can't take them just as gospel figures. Where does the data come from? Where do you get all the data? Well, basically nowadays it's big data. It's all stored electronically if you're lucky. Remember I said if I do an inspection I might get locked in a room with a table and filing cabinets. Happens an awful lot of the time. But I'm just using big data because it all goes into that, especially if you're using building information management or building management systems, BMSs, which we're going to look at in a sec briefly. The information can be handwritten notes, Excel spreadsheets, Word documents, videos, photographs, three-dimensional LiDAR scans, consultant specialist technical reports. They could be scientific test results, loads of sources. Also, the maintenance records. So when was the lift last maintained? What was done? When was the fire system maintained? What was done? All of that sort of stuff. The cleaning. The cleaners, they can give very good information back. Never underestimate the cleaners, because they can tell you stuff you just don't know. You'll get prior warning of things going wrong, or things that have gone wrong, but they're in a corner somewhere and no one's noticed it, like a leak. Always respect your cleaners there. So it can come in different formats, your data, and there's loads of ways. You get that data from one-to-one conversations and interviews with people. Element coding, which I seem to have forgotten to put in for some reason. The National Public Works Council and the old lecture touches on this. What I wanted to say on top of the old lecture set of these, this breakdown that you'll see in the old lecture, go and Google it, find it yourself, is the same breakdown that we would use when we were doing a condition assessment. So we would assess each of the elements that's in this. There is another one that you can use. The quantity surveyors and valuers use something called the Green Book, but it's very, very similar to this and breaks things down. I'm not going to expand it because I want you to go and look that one up, because that's quite important, and you've already been given a hint in the old lecture. It's just I forgot to copy and paste in the one I had. Building management systems. Now this is what exists before building information management came along, and building information management is slowly absorbing these building management systems. But a building management system, it's got maintenance systems recording what needs doing and when it was done and who did it and how much. Financial systems, it can be operated remotely, so you can look at other sites. There's operator stations which might only be in the maintenance room or in the air conditioning room or in the building manager's office. And you can manage things like the boilers remotely, and they'll all be monitored, and your chiller plants all monitored and controlled that way. Variable air ones, lighting can be controlled, electrical meters measuring everything that's going on. There's not just 1 meter per building anymore, there's meters for everything. You can run remote locations. I used to do this at the Department of Justice. I could see what other courthouse air conditioners and that were doing at the time just by calling it up on the computer. Tenant control, that's security, so that you can control what areas certain people can get into, because you don't want people having access into everywhere. Business systems, that's strategic reporting, etc. Back to the maintenance. It all goes into these. This is the technical stuff you don't really need to know. We're interested in this outer one. And it all goes into a computer system, which is, as I said, being taken over by building information management at the moment. And just to recap on what we looked at before, the difference between the preventative and the corrective maintenance. Preventative, periodic, predictive, we know it's coming, it's not a surprise. It can be based on a time limit, or it could be regular, like a lift would be a regular, and gas boilers and chiller units for air conditioning, all regular. Periodic ones can be unknown, but you know, predictive, you know what they are. But the corrective ones generally only comes up when something fails. You might know the equipment condition, you may not. The condition would be fouled. You will find a lot of that during a condition assessment, that it's fouled. And the maintenance action is a corrective replacement or restoration, you know, for a failure. Otherwise, you service it for preventative unless it's unexpectedly gone wrong. And that doesn't happen. You maintain properly. That doesn't happen very often. So that's my top up on the old lecture. Watch the old lecture and this one. This should be enough to keep you going now for a while. I'm just going to do week 3 now. I'm going to upload this one and hope it's worked. And I'll be posting it to everybody individually as well as just putting it on the team site. So let me get on with number 3 now. Ta-ta!